Okay, in this short video, I'm going to talk about the inverse tangent function. So remember that if y equals the inverse tangent of x, that means that tangent of y equals x. In other words, the inverse tangent function gives us an angle whose tangent value is x. And we have to have a little bit of understanding of what the tangent function looks like. So let's look at the graph of the tangent function. Notice vertical asymptote at negative pi over 2 and over here at pi over 2. And the tangent function is periodic with period pi. So in order to have an inverse, we have to restrict the domain. And we're going to restrict it to the interval from negative pi over 2 to pi over 2. So we're looking at just this blue graph right here. Okay. And when we look at the inverse function, the graph of that is just reflected across the line y equals x. And we get this graph over here. So here's the graph of the inverse tangent function. All right. So when we're doing the inverse tangent function, we only get angles that are between negative pi over 2 and pi over 2. So the inverse tangent function gives us angle values that are between negative pi over 2, right here, and positive pi over 2. But the input, the x values for the inverse tangent function can be anything from negative infinity to infinity. And it's interesting to check that out on the calculator as well. Okay, so we're going to flip to the next page and we're going to look at one quick example where we're going to find the exact values of some inverse tangent of the inverse tangent function. Okay, so tangent inverse of 1. So what we need to remember is our unit circle. And if tangent, so I'm looking for an angle whose tangent value is 1. Let me call that theta. Let's just call it theta. Then let me put it over here. Doesn't really matter. That means that the tangent of this angle theta is 1. So remember your knowledge of the unit circle. Tangent is sine over cosine. So in order for the tangent of theta to equal 1, the sine and the cosine are going to have to be equal, and that's going to happen when our angle is pi over 4. That's the only time it's going to happen. So tangent inverse of 1 is going to equal pi over 4, and we are finished. Okay. All right, let's do tangent inverse of 1 over the square root of 3. So again, knowledge of our unit circle, and because that, well, let me just look at my angle theta. Theta is going to be an angle whose tangent value is 1 over the square root of 3. So we're looking for a first quadrant angle. And the tangent value has to be 1 over the square root of 3, which, if you remember, is also the square root of 3 over 3. What do I need to have? So let's think about this. Square root 3's happen. So we have to figure out if it's the pi over 6 or if it's the pi over 3. Those are the ones that have the square root of 3 in them. Okay. Tangent, like we said, is sine over cosine. So is it going to be this one where I have the 1/2 divided by the square root of 3 over 2? Or is it the pi over 3? Well, think about how fractions work. If I if I do the division, I need to flip that and then multiply. There's my 1 over the square root of 3. So the angle that we were looking for is the pi over 6. Okay, arctangent of negative square root 3 over 2. This time, we're going to be down here in quadrant 4. Remember, tangent inverse keeps you between negative pi over 2 and positive pi over 2. But since this is a negative value, we need to be in quadrant 4. So again, it's either going to be our pi over 6 for our reference angle or our pi over 3. And the last one was the pi over 6, so this one needs to be the pi over 3 because this really is negative 1 over the square root. 3? Oh, it's the same one. It's not our pi over 3, it's our pi over 6 again. But it's going to be negative pi over 6, right? So we need that same ratio, but negative this time. So this is going to equal negative pi over 6.